at some point. Yay, there we go.
Yeah.
And Hoshin, I was wondering, with this foundational model, what would be the goal? So what would be, is there a goal to predict something? If so, what? So what would be the goal of such a foundational model?
Again, all to be discussed at the next meeting.
Okay, I see.
But I guess you could ask a similar question of, what's the purpose of building a large language model or a foundation model in any context? And very often you're not quite sure what the uses are going to be. You start with a few, you start with some few ideas about how you would use it, and hopefully it would presumably then take on a life of its own. So, but the idea would be that if you have a problem, you would then have access to this very extensive database, and you could use machine learning technologies to find patterns in that data, which would then be useful for understanding and predictive purposes, which otherwise you would have to impose from the outside, then go look for data to support the idea. So to kind of like turn it around on its head a little bit.
So one of the most crucial steps is to have some kind of huge common database where you can easily access from. So this involves a lot of creating maybe data standards and things like that.
That's right. Yeah. So it's a very ambitious idea. But if we knew how to do it, probably it would have been done already. So it'll be interesting. Yeah.
Laura?
So regarding the data, do we have already the infrastructure to start saving the data? Because that's gonna take some some space in a repository, people having access to that. So those are things that we have discussed in NSEC workshops, where even if you just started a project and you have your proposal approved, you have to deliver your results, even if you haven't published the manuscript through a repository.
Laura, let's hold all this discussion for the next meeting.
Okay.
I certainly don't have answers to any of these questions, but that's the whole point of having, the thing to try to figure out what the frame would be, so that an appropriate effort could be mounted. Maybe in the beginning you'll start with this, with a small subset proof of concept. I'm sure large language models started like that too. You didn't toss all the data you could get at it. You started with something small to develop the ideas. But I don't know. So I'm curious to hear what Jonathan has in mind. Okay, so we'll hold that discussion for next week, for 3 weeks from now. The other sort of activity that has been given some thought, and I've talked to already somebody to develop that came out of this meeting, is something that I talked about with Dan Kovacek, who works with Stephen Weiss in UBC. And the idea there was to take a page out of sort of the artificial intelligence community. And you may be familiar that in the artificial intelligence community, there's something called the Hutter Prize. Anybody heard of this, or people heard of the Hutter Prize? So Marcus Hutter is one of the leading proponents of developing general artificial intelligence. And one of the things that he's pointed out that is central to information theory and to machine learning and to intelligence is the idea of compression. And so what does that mean? Compression is basically, how do you achieve compression? You achieve compression by finding patterns in data, right? Models are one way, physical models, theoretical models are one way to impose patterns on the data and then subtract those patterns out. Other ways are to use machine learning or empirical approaches. And if you remember our discussions on algorithmic information theory, when you talk about an object or a system or whatever, the definition by Kolmogorov of the complexity of that system is given by its description length after all redundancy has been removed, right? So a completely random string of digits, binary digits, has the maximum complexity because there's no redundancy that you can remove. But if you've got patterns in there, you remove those patterns and then you shorten the description length of the data set. So this is the idea of minimum description length. And the idea is that the problem with Kolmogorov complexity is, as an information theoretic notion, is that you never know what is the shortest description length of a data set. You have to figure it out. And you may think you have a description, and then somebody else can come along and they can find some other pattern in the data, some other redundancy, either statistical or deterministic, which has not been exploited, and then they can come up with a shorter description, and so on and so forth. So any description that you have of the data which is compact, such as running a compression algorithm like zip or any of these other compression algorithms, is only going to be an upper bound on the complexity of that data set. And as an example, if I give you the digits of pi, 3.1417, whatever, and you run tests of randomness on this sequence, you'll find that it passes all tests of randomness. But we know that that sequence is actually a deterministic sequence, which is generated by the operation of calculating pi as the ratio of two integers, right? So, or the algorithm related to the properties of a circle. So just because your data set passes tests of randomness doesn't mean that you have extracted all of the pattern information in that data set. So what Marcus Hutter has done is he has proposed what's called the Hutter challenge, compression challenge, where he took a segment of Wikipedia from some point in the past and he archived it. And the challenge is every year people get to try to demonstrate that they have a better compression algorithm. They can take that Wikipedia data set and they can compress it down to a smaller number of bits using some well-established set of rules. And every year somebody comes up with a better way of compressing that data set. And so they keep pushing down the Kolmogorov complexity. And the idea is that learning or intelligence is basically directly related to compression, the ability to extract patterns from data. So of course, he's very interested in this because if you're going to create artificial intelligence, one of the important components of AI is the ability to find patterns in data. And you want more and more intelligent ways to do that. So one of the things that I've been talking about with Dan Kovacek, and Stephen, is the idea of creating something analogous in hydrology, for example, like Hamel's dataset compression challenge or something like that. And so Dan is looking into that, and he is proposing, Leela, he hasn't gotten back to you yet, but I got an email today. He's proposing to make a presentation on that sometime before the end of the year, and then maybe follow up in the new year. And so he'd like to discuss that with the group and come up with, interesting, intelligent ideas about how to design that. Because right now, people are taking the Camel's data set and they're running machine learning algorithms on it, and they're just focused on performance, predictive performance. But really, we want to be focused on both predictive performance and compression, because compression would imply we're actually learning something in a compact fashion. We're extracting some kind of interesting information about the patterns in the data set, and hopefully lead to better insight into how hydrology functions, as an example. So that's a second idea that's come up. Any thoughts or questions about that? But as I said, we'll come back to that before the end of the year.
If I may, I imagine that this is lossless compression, right?
I guess that would be part of the discussion.
You have to be able to restitute the original data back to its form. Okay.
Sure. I mean, I think we could probably explore lossless and partially lossy compression if we could justify the loss, right? I mean, arguably, most physics-based models are lossy compressions of the data. So there may be benefits to doing lossy compression if we actually learn something interesting, which can be generalized and taken from one place to another. But of course, the push to do lossless compression would be the strongest push to drive learning, right? Yeah. Great. Holger.
If we are interested in both predictive performance and compression,
Yes.
Then we have two kind of scores. Score one is predictive performance, score two is the compression. And do we have a kind of smart rule how to make one score out of the two? So in order to make sure that we are interested in the right thing?
Yes, so absolutely. So the whole idea behind minimum description length is that if you can describe the original data in bits, so universal measurement scheme, how many bits do I need to store this data with a certain level of precision? Then you need to both describe your compression algorithm in bits and your residuals, the error associated with that compression. In other words, to be lossless, you have to also preserve the residuals. So the sum in bits of the length of the compression algorithm plus the residuals, the part that is not perfectly compressed, together, those two in bits should be shorter than the original data set. And it's that total sum that you're trying to drive down.
Okay, thanks. But this raises the next question. If we go to, let's say, lossy compression, then we also would have to take into account the loss there in a kind of bit length, right?
So that's what I just mentioned. So you have the algorithm. If the algorithm is fully lossless, then there is no error associated with it. Okay, so there's no bits associated with the residuals of the error. And if you're
I see. Yeah, I see. Okay.
partly lossy, you will have error. So you take the whole sum together, and because that whole sum together is able to reconstruct the original data set.
I see. So the lossy part would be in the predictive performance.
That's correct.
Okay, thanks.
That's right. Yeah, it's a very clever idea. Doing it is a challenge.
I'm just gonna say something funny. While you guys were talking, I was imagining the Darcy Weisbach loss equation of transfer of water from one point to another, and then the losses in the middle.
Sorry,
the friction losses.
Right. Okay.
But Hoshin, a question. So you are right now in a proof concept type of work. So just all the data is coming from Wikipedia, or what would be the goal?
So the Hutter
Go ahead.
The Hutter Prize is dealing with Wikipedia. Here, the idea would be to take hydrological data sets. And there's some preliminary work done by Stephen Weiss. You can look up his papers where he did what's called hydrozip, where he was testing some zipping compression algorithms that he designed himself for catchment classification. And he was comparing that to standard programs like are on the website, that you use, like MP zipping algorithms and other ones that are there. His idea that was very interesting was that the amount of compression that you can do on a data set is an indication of how complex the system is. So if there's a lot of structure, then you can compress the particular data set quite a lot. And if there's not a lot of structure, you can't compress it a lot. And so his idea was that you could use that to help you understand the different degrees of complexity of watersheds around the world, right? But you can read the paper. I don't remember the exact details right now.
Yeah, that's good, but it would be nice just to, I mean, you already have the data, so if, you know, the bytes are determined by the data collection, and then you start the compression
So one
technique.
idea,
So what
what-
about if you have the data, but the data hasn't been output from the source, and that would be more significant if you end up with a, you know, with a compression that doesn't really have to evaluate the data set. It's just
the one idea,
evaluate the data once while the data is actually taken.
so as I mentioned, Dan is going to talk about this.
Okay.
But the idea would be we would choose a particular data set, just like Marcus Hutter chose the Wikipedia and archived it. We would choose a data set like the Camels data set or something more extensive. And, you know, you would have to come up with the rules for how to describe it in bits at whatever resolution and so on. And so you would know what the length is, and you would have to have all of the rules for how you're going to measure the compression. So there's a lot of details to work out. Yeah. But the idea is it would drive more than just predictive performance. It would be driving both predictive performance and hopefully better understanding by extracting structure from the data set.
Hoshin, you said there is, Stephen Weiss has a paper on that. Could you share that after the talk today, or if you find it later? It doesn't need to be now.
Yeah, I can do it right now. Type in hydrozip. Go ahead.
If I make a short interruption, so yes, we might need to move to another link, a Zoom link, because I am not able to extend this meeting further than 40 minutes. And so I just copy and paste the link in the chat. So if we all can transition now to that link, it'll be awesome.
Okay, 1 second, guys. Let me just post this link and you all grab it.
Got it.
And then, so you can grab that. And okay, see you all guys in the Zoom meeting link that has just been posted.
Sounds good.
Do we need this meeting ID or it should go in automatically?
It should go automatically.
Okay.
Yeah.
All right.
Okay. See you soon.
Describe a model in, so, you know, encode up a model and describe its description length in bits in such a way that you could then measure the bit length of the model. You could measure the bit length of the errors that come out of that model. And then you could compare models on an even playing field, because obviously you have a more complex model, you've got a shorter bit length of residuals, but the length of the model has to justify, you know, if you make it more complex, you have to justify it by making the errors small enough that it compensates for the fact that your model gets longer. The question is how to actually do that, how to do that encoding process, and that's something I've been thinking about. So that's my commitment or proposal. Yeah. So who wants to go next?
And so, Hoshin, when you, oh, sorry.
No, you go ahead.
Just a clarification. When you talk about bits of compression, you're talking about algorithmic compression or just the entropy quantification of the distribution of values and how many bits? Or
I'm talking about algorithmic compression.
Algorithmic compression.
Yeah. So, you know, we don't need to get into questions right now. Just each of us just go around and either raise your hand or I'll pick on you.
I can go.
Okay.
So for the past few months, I've been working on getting LLM to simulate discussion in order to tackle decision-making process in the context of climate change, assessment of extreme events, etc. So my research isn't that far advanced that I can present it yet, but so I guess most of you know I've been working, I'm a PhD student with Professor Pravin Kumar, that has a strong history on causality, of course. So he made me read a bit about causality, and from a couple of papers recently, I could just touch a bit on the fact that there is an ongoing controversy or debate whether LLMs are able to infer causality, just because they get bigger and bigger and they represent the human language, which is the support for thinking and making cause-consequence relationships. I imagine that could be a very simple way of describing the thinking and causality process. Whatever, there is a debate over the fact that LLMs are able or not to infer causality. And so I've read a couple of papers on this that seem to go towards the way that they are not able to infer causality, but they still have a balancing conclusion that say they are not yet able to infer causality. I mean, not in a general fashion. So I've been reading a bit about this, and I'd be happy to dig a bit deeper so as to generate a discussion on that topic if people are interested.
I think that's great, and actually, that's exactly the kind of thing that I'm hoping that we were hoping that the group would do. You don't have to come in with fully formed ideas. In fact, half-baked ideas that we're trying to explore and having a community to discuss them with is exactly. I mean, my ideas about how to do description link are also half-baked. So the whole point is to use this as a kind of a whiteboard, you know, to get feedback.
Okay, great.
Perfect. Okay. Who'd like to go next? Yang.
So my current interest is to use like generative modeling approach to do hierarchical modeling. So basically, I want to find a simple equation that can a simple function that can produce more functions that represent the catchment function. So like a generator of catchments, a hypothetical catchment that like tells us about like how catchments are similar to each other, how catchment evolve in their like generative space, because in the generative space we can represent a catchment by a few parameters, describe their like latent characteristics. Like so in that space we can more easily study their relationship and study how catchment evolve through time and through human impact. So that's my current research direction.
That's perfect. Thanks, Yang. And I can see already this would be strongly related to the compression challenge idea. So from a completely different perspective, that's great. All right. That's 3 up.
Well, Hoshin, I don't really have ideas. Can you just like explain your problem and then we can discuss ideas from there?
Absolutely. Absolutely.
Okay. And also, you know, if you have limited knowledge on that topic, can you know, you have some results and then you can say, oh, okay, this is how I envision and these are my goals, and how can we come up with a solution?
Yeah, I think something like that would work, provided you've done some work to think about questions that you want to bring up in front of the group, you know, so that it's not just, oh yeah, okay, we understand what you're doing. You know, you want to try to use it as an opportunity to pick people's brains. So you try to have some, you know, some targeted sort of questions that you ask people to try to give you responses on. Okay.
Yes.
All right.
Do you want me just to give a 1 minute explanation of what I do or?
Well,
No.
when you have an idea of what you would want to use as the basis for your discussion, then maybe just write up a paragraph or something, or if you're ready to explain that now, we could do that.
Okay, so my work is not in hydrology, it's actually in in turbulent flow. So I work with physics-based models, Navier-Stokes equations, and continuity equation, and advection diffusion. Those are things that are, supercomputer models that are widely used in atmospheric science for boundary layer meteorology. So the causality is right there into the physics of the model. However, we have a lot of problems with the expenses, computational expenses, and predictability of the models. The models can explain hidden patterns and like vorticity and eddy structures that cannot be observed, but our idea is to go to surrogate models. And in that, we can talk about compression, but in another way, you don't have the data. We have a data collection, which is not data, actually simulated data. But my interest is more into when you are creating the outputs of the model, you may have to start embedding the compression before the outputs. I don't know how to do that. Predictability using models like ClimaX that were proposed in HydroML using GPT networks, LSTMs, GANs, and things very much out of the box is art and how to create art from DALL-E. But I don't think that actually fits here because it's more about gender equity and how we perceive ourselves in academia as women. I wouldn't. Those are my ideas. I don't really have answers to any of them.
Sorry, I was muted. I definitely think there's something in there that we could all discuss. Certainly, it's a very hot topic, replacing machine learning models replacing physically based models with machine learning models, or figuring out how to hybridize them, or figure out ways to make physics-based representations easier and faster to solve. There's a whole big area in there. So yeah, why don't you go ahead and write up a paragraph and send it to Lila, and then we can get that on the schedule. All right. Luis, do you want to talk about hydro-LSTM at some point?
Okay. Yeah, continuing with the idea. Yeah, no, it's okay. No, because it's really related with the idea of compression, because what I'm working on is trying to compress the representation that we're using, but trying to get kind of this, from this compression, learn this kind of pattern, but this pattern should be kind of hydrological meaning for us. So in some way, I'm trying to extract this knowledge, trying to compress the representation at the same time. So for the question, all these kind of topics related with compression and how we can learn from that is something that I'm interested in.
Yeah, and I think the things that we could learn from your work, from Yang's work about, are there typical catchment types? Can we come up with a reliable catchment classification system or not? There's already some work out there which is starting to make progress in that area, but my understanding is it's happening because people are trying to apply machine learning techniques. So, okay, so we'll get you on the calendar there. Yes, Andres.
Yeah. Yes, I'm really looking forward into the compression of data and algorithms we are discussing here. My work is more based on the knowledge generation from explaining the machine learning models than the accuracy, but you cannot do one without the other. You don't want to explain a model that doesn't work well. So I have found that it doesn't matter really how complex or how good your architecture is. as long as you don't have good data to build your model. Like I've been trying to explain the biases in the gprof measurements over the world, but well, the way this sensor measures is brightness temperature from the top, and there is a lot of noise in that data. So I think my principal barrier in this project has been dealing with this noisy data that I had to assume that is true, that is the right one. So yeah, I'm really looking forward into the discussion of compression, like finding the patterns, like getting the most out of the data first before getting into the building part of the models and those.
Excellent. So are you proposing to lead a discussion on something specific?
I will love to participate into the causality discussion that Antoine mentions, but I don't feel that I'm ready to lead it. I would love to collaborate.
Okay. Well, certainly, certainly everybody here will be engaged in the discussions. What we're looking for right now is not so much support, because whoever says they want to discuss, we'll get them on the calendar. What we're looking for right now is volunteers to get on the calendar and to lead discussions, and it could be either on your own
and
work,
to bring topics and
or it could be a paper that you read that you think is interesting. So there's a lot of flexibility there. Yeah.
Okay, cool. Yeah.
Okay.
I'll be down for that.
Let's see. Who else I know is already doing stuff? Manuel, what do you think?
Yeah, I was thinking, well, my current research focus is on very much model development. So I was thinking that something that could be useful is we could point to a paper in the literature and then explain or discuss the paper, of course, and then explain how this paper applies to our current work. So for example, if I would want to start a discussion, then I would point to the paper of one of the different model building frameworks that have been proposed in the past, and then I would say, well, this is why this previous work has inspired my own, and this is what I want to do next with flexible model building. So, and how also the point of view or how information theory can be used in this previous work that has been done. So I think it would be a nice idea for the overall concept of these meetings, that you could point to something in literature, how it applies to your current work, and then what you're trying to do with it.
Great. So do you have something in mind that you'd like to bring up?
I could do maybe later in the year, because I'm currently in a critical phase of my PhD.
No, certainly. Yeah, certainly. It does. We're not committing you to a specific time right now. We're just getting you on the calendar.
Yeah, but a discussion on how you build models, how you put together models, and how you can use different methods to determine if a model is misspecified in some way. I could do a discussion on that.
Excellent. That would be actually a nice complement to my topic on description lengths. Yeah. Okay.
I guess
can go. Oh,
Allison,
go ahead. I want to do something on causal discovery, because that's what I was about to say. I'm looking for an excuse to pull together some papers and thoughts about information theory based causal discovery, and particularly multivariateness, and to what extent models are using different subsets of sources of different sizes relative to the kind of like the full size of all the information that they're given. And I'm at a very half-baked stage with it, but that's something that I would like to present about at some point.
Great. Excellent. Thank you, Allison.
Yeah, that actually sounds wonderful, Alison, because in my PhD work, I work with causal discovery for understanding how is the structure of the interdependencies among variables. But now I am facing the issue of very high dimensionality for all the problems that I am working on right now. So I am trying to find a way using machine learning techniques and causal discovery and all kind of techniques that helps me to really reduce the problem to a good subset of variables that can be used for not for prediction but for better understanding the structure. And I am wondering if I can find if that structure actually evolved or not over time. So yeah, I'll be interested in discussing more on that.
So there's a strong component of dimensionality reduction or manifold learning.
Yes.
To your work. Excellent. Yeah. And the people here could probably help with that. Let's see. Isabella, do you have some ideas you'd like to bring with the group?
I was thinking like I'm working with a hydrological model that is called WIP. I don't know if you have heard about it. It's like an integrated approach. It's like a tool. So I'm working with the Red River Basin that is composed by 90 catchments. So I was wondering like how we can calibrate using machine learning, but like in the inverse problem. So how we can give to the models the simulations and to try the parameters by machine learning. So I would like to discuss how we can do that later. I don't know, like those are like my ideas.
Okay. Do you have a specific thing that you'd like to bring before the group to discuss?
I don't know. I can just like I don't know, like yeah.
I think you showed me a paper, Isabella, last week.
Yeah.
I think you
sorry,
could probably
yeah.
propose that paper too.
Yeah, I show a paper and that's good. It's a really good one, and I have been like read it, so I didn't understand the question. Sorry, but yes, there is one paper we can discuss probably. There are some that we can discuss. So,
okay. So I think what you're talking about is also very strongly related to some of the work that Yang is doing on latent vector embedding and, trying to estimate parameters that way. So yeah, I think you'll find some good conversation there. Holger, did you have your hand up?
Oh yeah, but just because, no, not because I needed to be the next one. I have several things. First of all, what you mentioned, Hoshin, with the minimum description length is super interesting for me, has been interesting for me like for 6-7 years. So I still wonder how you can find the minimum description length of a model. So you're having a model described as an ODE. How can you describe it in the shortest possible way? So that's also what I asked to Peter Grünwald, and I think that's super interesting. And I still have no idea about it, but might be useful to read his book. I'm not sure, but that's a lot to read probably. The other thing I'm also interested is causality. Jakob Runge was invited to the workshop and couldn't make it. And I'm interested in using his Python package Tigramite to find causality between time series. And so far, I have no idea actually how to use it because there's lots of theoretical knowledge behind it, lots of literature. So I'm not sure how much, because I'm new to this group, how much you have already read about this causality papers that might be behind that. If not so much, could be interesting to read one of those and present it.
Sure, that would be great, Holger. Another and complementary to that, you could even just invite him to come and give a presentation to the group.
Yeah, he doesn't tend to respond to my emails so much. So.
Okay.
And the other thing what I found as a buzzword on the workshop program was the information bottleneck.
Yes.
I'm not sure either how much you have already read about this here in the group, but for me that was interesting because I was wondering with this new types of entropy I came up with for compartmental systems, if we could use entropy values for different pools at different times to identify bottlenecks in the modeling process, so that we can identify, okay, here we are at the limit, we cannot model it better. And so my vague idea was this could have to do something with the buzzword information bottleneck. But that's basically all I know about that. So I would have to read about that before I can say more. And I don't know what you have already done about that in the group.
Okay, so that's great that you brought that up. It's certainly a topic we should return to. In the meantime, if you go to the ITS website, we do have one YouTube video where I did an introduction to information theory, information bottleneck.
Oh, that's good.
And so that might be a good place to start. And then we could continue the conversation because yes, there's certainly a lot more. One of the ideas I had, Leela, was that I had identified actually a talk by Tishby.
Yes.
And one of the weeks we could just play the talk, right? We could just watch it all together and we could periodically stop it when people have questions. And I think we could also benefit a lot by watching it together and discussing it. So that's another thing related to information bottleneck, particularly in the context of machine learning, that could be useful to do.
Yeah, so what I'm really interested in is how we can use information theory in some sense to identify that our model is doing okay. Let's say our model results are bad, so we can predict very badly, but that's the best we can do because of.
Fair enough. So it'd be great if you would be willing to lead a discussion on, as you said, pick a paper or something, and then combine it with these. It could even be some presentation of the work that you showed in Germany. That's relevant to your discussion.
I showed already everything and even way more than I know.
Yeah, but only a small subset of the people that are in this discussion group are actually at the workshop. So and certainly I would be very happy to hear it again, because hearing it one time is certainly not enough. One thing off the top of my head is that Gray Nearing has written a paper where he basically points out that a sort of an estimate on an upper bound on performance on a data set that we have using machine learning, right? So you get an idea as to at least how close are you with your physics-based model to something which is able to extract the patterns from the data. Obviously, that bound is not going to be a firm one, because somebody can always come up with a better way of compressing the data, but it at least is a way of driving driving it forward. What is not clear is how do you figure out as to where the errors are, and where do you have to focus on?
Yeah,
that'd be an interesting topic.
Yeah, what I could propose, but I don't know exactly when, is read something more. For example, watch the Tishby video and your introductory video to that. Maybe read one or two papers and try to bring it together with the ideas that I presented for the compartmental systems modeling, which is still very vague. So
that would be perfect. And so what I would do is, I think Leela's taking notes, so she'll send out a list of dates for people, and then first come, first serve. You get back to her and say, I want this date, and whoever gets back first gets that date, right? Yeah. So if you want to be near the end, you can respond.
I will be unavailable for December and January.
That's fine.
And before, I'm not sure if I can make it.
That's fine.
Because it's a lot of reading for me involved in the first place.
Of course.
But I'm happy to do it because it's interesting.
Yeah, and it doesn't have to be fully formed, right? I mean, you could bring in a work in progress. Yeah.
That's what I tend to do always. No worries.
There we go. Like the rest of us. Let's see. Tim, did you have something you wanted to bring with the group?
Oh, sure. I mean, you've heard it before, and I'll let Hoshin set the stage because he does it so well. But I would be interested in continuing to develop ideas about how we apply information theory to model evaluation. And just sort of a quick motivating note, and I think Stephen Weiss sets this debate up nicely, but it's somewhat contentious in science whether the goal of your model should be to maximize value or utility, or to maximize information, and that's a valid debate. But there are very important models that it's very difficult to evaluate on utility terms, like a climate model. Our future depends on the output of these models, and it's very, because they predict so many parameters and have so many different uses and users, it's very difficult to define utility with those models. And our only hope to evaluate them, I would argue, is through information theory.
Yeah, I think that would be an excellent discussion. When you mentioned utility, what comes to mind for me is, information is always information about what, right? And so utility is a kind of a way of focusing your attention on what it is that you want information about. And a lot of our models could potentially be used in many, many different ways. So they might be very utilitarian for one purpose, but not very good for another purpose. And so there's no like single metric clearly, which says, but you kind of have a Pareto frontier, right, of different purposes you might want to use your model for. So that could be an interesting conversation. Great, thanks, Tim. Let's see, who's left? Valentina?
Okay. Turn up. Yeah. Hello, everybody.
Hi.
Now, what can I say? Well, I'm just starting in this kind of topic. So for today, I don't have nothing. I'm just listening. But yeah, it was so interesting to me.
So maybe something interesting that you could do, Valentina, is pick a paper on a topic that's of great interest to you, and read it, and then make a presentation on that, and we could discuss it, because we would all benefit.
Okay.
Something you're interested in, I'm sure we would all benefit.
Yeah, I'm gonna do that.
Sounds great. Let's see. Leela, you got a note here. I think we'll just be another 10 minutes or so, not much longer. Yuan, is there something you want to bring to discuss with the group?
So I was actually thinking that because we are right now working on a interpretable computational node, and I already test some case with different flow paths, multiple serial and parallel structure, and also some variant of single parallel layers. And I think that ties together with the idea of also complexity, how you quantify the number of nodes and links. So maybe that could bring some insight to the discussion about the complexity. Yeah.
Okay, so model complexity discussion using the mass conserving perceptron node that you've developed. Yep. Yep. Perfect. And let's see, who's left? Chris.
Do you hear me now?
Very clearly.
Okay, perfect. So right now I'm working in model predictions and different metrics. Actually, what you were telling a bit about this kind of Pareto front for diagnostic metrics. And before I was working more in model selection via hypothesis testing. So I am wondering if, and I am interested in three things actually. One is foundational models. Actually, Jonathan sent me a paper that I could read and present, and the minimal description length and evaluation metrics. So I could either present some of my work in hypothesis testing, or present a paper basically.
Okay.
What is more interesting for the people? I mean, I am happy to present my work. I mean, or move forward for the other option, but also in my case, it need to be after January.
Okay. Well, I think you're the one who
and
should.
one something else. Sorry, Hoshin, one thing that I close to forgot forget. I'm working with actually Gray and Martin with my PhD student, and we are looking at outlier predictions and including uncertainty with LSTMs. So maybe actually also my student would like to probably join.
Okay, so Leela, we've got 2 possible presentations from Chris's side.
Awesome.
Yeah.
And one of
Thank
hers.
you.
Okay. So, okay, thanks, guys. So we're just a little over time. Leela, is that okay with you now? You've got a list of proposals. And if you
Yes.
could put the calendar together, you know, obviously avoid AGU and avoid the winter break.
Oh yeah.
For sure.
And you know, try to get some judgment on whom we can get on the calendar before AGU, and because I think some people are probably more ready than others. But if you can start with a straw man, put people on a calendar, and then get them to commit to a specific date, that would be great. Yeah. Also avoid EGU, of course. Yeah, but that's
Yes, sounds
far
good.
enough in the future. I'm not worrying about it.
Sounds very
Okay.
Okay. So the impression I got is that some people who could go relatively quickly would be myself. Hernan, I missed you. Yang, Luis could go. Yuan could go. Antoine, I think, said he could be fairly. So we got a fair number of people who could go in and.
I think Jonathan, Jose, Jonathan too. Next for next presentation.
Yeah, Jonathan's already scheduled. Yeah.
Yes.
Okay.
Hernan, I'm sorry, we forgot. We didn't give you a chance, so you don't get to escape.
Oh, okay. I was squeezing out. But anyhow, this is great. I think we have enough material, but I just have a couple more of ideas. One is I'm pretty interested in what happens in space and predictability of things in space. So think about an image of something. And so one of my questions that intrigued me that I'm going to try to research into is the entropy of an image, the entropy of the distribution of the values within an image, and how can the neighbors inform about the values in a certain element in an image. And think about distributions of precipitation, think about distributions of snow, think about distributions of anything that you can take up an image and then use to understand the spatial autocorrelation. There's been some progress in this along this line with the local Moran indices that measure spatial autocorrelation. But there is a good paper that was published a few years ago on entropy as a measure of correlation that's pretty well linked to the variogram in when you use interpolation to figure out what's in the middle. But it seems like entropy provides a little bit more information into what scales are relevant to learn, what distance is relevant for what process. And that's actually a pretty good question for us hydrologists to try and understand things in space too, not only in time, because the flow of information from those neighbors matter a lot for the correct predictions of time series.
Sounds very interesting, Hernan. Yeah, clearly extracting structure from spatial images is related to the whole compression challenge, and could probably be also related to convolutional nets and transformer architectures and so on. So do you have a paper in mind that you want to bring?
I just put one, yes, in the Excel spreadsheet. It's called the entropy-based local indicator of spatial association.
Okay. Maybe you could send that to Leela, and we'll get
Leela. I will.
All right.
Yeah.
Okay, good. Any final comments before we break for today?
Yeah, I have a comment in terms of the presentation, because right now I am implementing storytelling into my presentations, whether it has to be really like the standard format, or I can use storytelling concept. So what I do is I actually pick a style or a structure, and then I use ChatGPT for the outline of the presentation, and after that I move forward. I can also just present as a regular scientific presentation, which it seems like in the community hasn't been effective enough for learning purposes.
Laura, you have complete flexibility how you want to do this. And as long as you can keep people's interest and involved in the discussion, I don't care how you do it.
Okay.
Yeah.
Mm-hmm.
I have a related question on that, Hoshin, because I've not been part of that now. How long should the presentation be, and then how long the afterwards discussion?
So we usually plan on meeting for up to an hour and a half, right? So anywhere from an hour to an hour and a half. So probably you want to limit your presentation to about 30 minutes to allow, a good discussion. And then if there's stuff you want to send out in advance that people can look at beforehand, you just provide that to Leela and she then sends it to the group. Yeah.
Okay, thanks. That's useful.
Yeah. I mean, we've gone 2 hours at times. It's pretty much how long you can keep people's interest and when they get tired and hungry. But usually an hour and a half is pretty good. Yeah. All right. Great. Thanks. Thanks, guys. That was better than I could have anticipated. I'm glad to see everybody so excited to bring their work forward for discussion, and all it needed was a little bit of prodding. So that's great. There's a lot of interesting topics there, and I'm looking forward to it. So the next meeting is 3 weeks from now, correct, Leela?
Yes, it's October 25th. And Jonathan will be presenting, and I will send the paper right after this meeting.
All right. Okay.
And for the Europeans, I want to mention it might be dangerous that maybe in the US they have already changed the time, and in Europe not. I know only back from behind that there is a shift of 2 weeks. So sometimes it's 9 hours, sometimes it's 8 hours, sometimes it's 10 hours. I don't know exactly what happens, but be careful.
Okay.
Yes, and
we have a fixed time, which is 10 o'clock Mountain Standard Time in Tucson. And so that one remains fixed and everybody else shifts, unfortunately.
Yes, and please pay attention to your email, because I will change the link to join this meeting. So we are gonna keep this link, but I will send an invitation for your calendars, so it will be easier for you to yes, confirm on the time.
All right, perfect. Thanks, everybody. It was great to see you, and look forward to talking to you again soon. And Yang, I got your letter. I'll be back with you very soon. Yep. All right.
Thank you, everyone.
Thank you.
Bye, guys.
Thank you very much. See you
Thank
soon.
you.
Bye.
Bye-bye.